Good morning, my YouTube viewers. In this video, what we're going to do is we're going to do a non-parametric test and test behaviors across different demographic groups. And we're going to write a program in Python to prove that. And so when we write our program, the first thing that we want to do is we want to import the libraries that we're going to need to use to execute the program. So the first library we're going to import is Pandas SPD, which is a data processing library that also creates data frames and series. And then we're going to import NumPy as NP, which is a numeric library which also creates NumPy arrays. And then we're going to import matplotlib.pyplot as PLT, which is a visualization library. And finally, from scipy.stats, we're going to import chi-square contingency. So scipy is Python's scientific library, and stats is the statistical module within scipy, and chi2 contingency is a test that you can use in the stats module. So what we want to do firstly is we want to simulate the data across different demographic groups. So the first thing that we're going to do in that regard is we're going to set our seed. And you need to set your seed so every time you run the program will initialize to the same values and it'll run the same each time you run it. So data equals age group and colon 18 to 25 times 50 plus 26 to 40 times 50 plus 41 to 60 times 50. So that means you've got 50, 81 to 25s, 50, 26 to 40s, and 50, 41 to 60s. And then the behavior, so you're going to have the behavior for these different groups of people as well. So it's going to be rarely, sometimes, often, always times 12 plus rarely times 2, and then rarely, sometimes, often, always times 12 plus sometimes times 2, and then rarely, sometimes, often, always times 12 plus always times 2. So that's your simulated data. So we're going to create a data frame. So df equals pd dot data frame data. So the data is going to become a data frame. We're going to check the frequency counts of behaviors by age group. So behavior counts equals pd dot crosstab brackets df age group comma df behavior. And we're going to check we're going to perform the chi-square test of independence. So chi-square, comma p, comma df, comma expected equals chi-square contingency behavior counts. And chi-square is like a test statistic. P is a probability. DOF is your degree of freedom. And expected is what you expect, the values that you expect to get. So we're going to print them. We're going to print the chi-square test results. We're going to print the chi-square statistic, the p-value, the degree of freedom, and the expected frequencies. And then we're going to print the data frame of expected columns, behavior counts, dot columns, and comma index equals behavior counts dot index. So we're going to go down to the bottom of the cell. And so your chi-square test statistic is 0.632. Your p-value is 0.996. Your degree of freedom is 6. Your expected frequencies are behavior it gives you your expected frequencies as well. And the expected frequencies are very similar. And the reason why the expected frequencies are very similar is because when we set up the simulated data, we use very similar data for the simulated data. So you can see the p-value is almost 1. So if we were doing a hypothesis test, then the p-value would accept the null hypothesis, saying that there's not a significance difference between the two. And we would reject the alternate hypothesis, saying there is a significant difference, because you can even look at the chart that we're going to go over the code for the chart, but you can look at the chart and you can see that for the most part there's not a significance difference. So they have the age groups, and then it's always is 12.67, often is 12, rarely is 12.67, and sometimes is 12.67. So that means it's very similar values between 12 and 12.67. So now we come back up to the code, and we're going to plot the chart. So behavior counts dot plot, brackets kind equals bar, that means it's a bar chart, comma fig size equals 6,4, comma alpha equals 0.75, comma color equals blue, orange, green, red. The title is behavior frequency across age groups. X label is age group. Y label is count. Legend is title equals behavior. Grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7, PLT dot type layout, and show. And then now what we have is we have a different bar chart. We have a stacked bar chart. So you can decide which bar chart you like better. So behavior counts dot div, brackets behavior counts dot sum, brackets axis equals 1, comma axis equals 0, dot plot, brackets kind equals bar, comma stacked equals true, comma fig size equals 6,4, comma alpha equals 0.75, title equals proportional behavior distribution across age groups. X label is age group. Y label is proportion. Legend is title equals behavior. And then your grid is axis equals Y, comma, line style equals dash, comma, alpha equals 0.7, PLT dot type layout, and then we're going to show it. So you have two charts. So this is the first chart, and we've already discussed the first chart, but we look at the second chart, and you can see that the second chart, the values in the second chart are similar. So for 18 to 25, the value that is the largest is rarely, and for 26 to 40, the value that is largest, it looks like sometimes, and for 41 to 60, the value that is largest is always. And so there's not a significant difference between the three groups, and that's why you have a high p-value. And so that concludes this video. And the next video we're going to be talking about another non-parametric test. So I hope that you decide to watch it.